This is Physics 102A, Chapter 4, Solutions, starting with number 69. This is Part 2 of Chapter 4. So with number 69, we have a steel cable lifts a concrete block vertically, maximum safe cable tension. What's the maximum upward acceleration of the block? Okay, the maximum upward acceleration is going to be occurring when we have the maximum cable tension. So we're going to consider this at the very maximums. Here's our force diagram. Tension up in the cable up, weight going down. F equals ma in the y direction tells us tension up minus weight down equals ma. So we can solve for acceleration. It becomes t minus mg divided by m. So acceleration 4,200 newtons minus 350 times 9.8. Divide all that by 350 kilograms and we get an acceleration of 2.2 meters per second squared. Number 75 involves a slope, a wooden block sliding down an incline, and there's friction involved, and we have to solve for the coefficient of kinetic friction. So I've drawn the force diagram where normal force, normal force is going normal to the ramp. We have weight going straight down, friction up the ramp, and I've broken down weight into a y component and x component, just like in the previous problems. Mg sine theta is the x component, mg cosine theta is the y component. From there we do F equals ma, both in the y and the x directions. So first in the y direction, F equals ma, the sum of the forces rather. So in the y direction that's n minus mg cosine theta equals 0. And what this tells us is that on an incline, normal force is equal to mg cosine theta. Now let's do F equals ma in the x direction. The sum of the forces in the x direction. So we have the weight, which is mg sine theta, the x component of weight, minus the friction force equals ma. Let's, in the next line, replace friction force with mu times the normal force. So there's mu sub k, and normal force is mg cosine theta. That's what we got from the y component, equals ma. The m's divide out of the equation. We can factor out g, and we get for a block that's sliding down an incline, acceleration is g times sine theta minus mu sub k cosine theta. From here it's algebra, solving for mu sub k. So I've taken this through the algebra. Divide both sides by g. And in this line I subtracted sine theta from both sides. Finally we have to divide both sides by negative cosine theta. So here's what I get. The mu sub k is a over g minus sine theta divided by negative cosine theta. And I get 0.087. That is the end of the Chapter 4 homework.